Hello everyone, welcome back to the channel. Alright, I have a quick question for you. How many of you have built an application where every single request goes directly to the database? Be honest, user clicks a button, the backend receives the request, and the database wakes up from its sleep, thinks about life for 3 seconds, and finally returns the data. We have all done it, right? There is no shame in that. But now think about a large application. Imagine millions of users opening the exact same product page or profile page. Do you think those companies execute the same database queries millions of times? Absolutely not. That would be a fantastic way to burn money and destroy performance at the same time. So, today we are going to talk about one of the most important concepts in backend engineering, caching. By the end of this video, you'll understand what caching actually is, why it makes systems dramatically faster, what cache hits and cache miss means. We'll build a complete working demo together. And to keep things focused on the core idea, we are not using Redis today. We'll simply use an in-memory Java cache and see how even a tiny optimization can transform performance. So let's begin. So this is probably the architecture most of us starts with. A request comes in, the backend processes it, and the database talks to it and gets the information and returns a response. Simple, straightforward, and perfectly fine for small applications. But here's the problem is databases are expensive. Reading from the disk is slow. Network communicates takes time. Complex joins, indexes, locking mechanism, none of these operations are free. Now imagine 1 million users are exactly doing this same flow. If we keep asking the database the same question repeatedly, eventually the database is going to file a formal complaint against us. And that's where caching enters into the picture. Now, let me ask you something. If you visit an e commerce website and open the same product page twice within 10 seconds, what happens? Right? So, let's see. I have opened an e commerce page of Amazon, and if I open any other product, let's suppose I'll open this one, Vivo Book. So, it opened instantly. Let's suppose I open some other product which I haven't gone to yet. So it takes time to load for a second. Now if I want to open another configuration for it, let's suppose 2021. So it's taking time, right? A very minor time. Now I'll open that 2021 again. See, it's very instant. The system remembers the answer it already computed, and that's the simple idea behind it. What powers some of the fastest applications on the internet. So you might be thinking, what is cache? So basically, cache is storing the results of expensive operation in a faster location so that future requests can reuse those results instead of doing the work again. So that's literally it of simple concept. No distributed systems, no magic, no advanced algorithm. Imagine asking your friend what's 15 multiplied by 17 is. The first time they calculate it, the second time they remember it. If you keep asking the even the third time, they eventually stop being your friend, right? Your database feels exactly the same way. What happens when users don't have cache? So let's imagine I have multiple requests. Request 1 goes to the user backend and database, right? And back to the users. The entire operation can take might 3 seconds. Second request is also same, so it will also take 3 seconds. The third request is also same, so it will also take 3 seconds. Without caching, every request performs the entire operation from scratch. So this approach increase latency, increase infrastructure costs, and limits how much traffic your system can handle. More importantly, it wastes work that has already been done. Now imagine with cache what happens. So I have two requests here, request one and request two. Let's see, introduce cache, right? The first backend checks for something is cache, whether the requested data already exists in the memory or not. If it exists, it immediately returns the response. If it does not exist, then it queries the database. So we have two concepts for it, cache hit and cache miss. Cache hit is basically user is requesting something and it got the response from the cache and it returns to the user again. So the response time might be 2 milliseconds only. What is cache miss? So cache miss is user is checking in the cache first as usual and there is no response for it. So cache is marked as missed. So it queries to the database and then from database it gets the result. It then stores in the cache before returning it to the user. So the whole response time of the request one would look like around 300 milliseconds. So it can take 300 milliseconds and this request can only take 2 milliseconds. So that's the difference of it because it's querying the database is one on the request list. So honestly, that's one of the biggest business model in software engineering. The first user pays the price, everyone after that gets the benefit. So all right, enough of theory. Let's build something. And notice something important. We are intentionally not using Redis today. No Docker containers as well, no distributed systems, no external database. Because if we introduce 15 technologies at once, everyone forgets the actual lesson. Today, our cache is simply a concurrent hash map, just memory, nothing more. The goal is to understand the concept before moving to production grade tools. So I'll open the demo project which I have built. The project is intentionally tiny. Product.java represents our data model. Database simulator pretends to be a real database. Product service contains our cache logic with cache hit and cache miss as well. And the product controller exposes a REST endpoint for us to carry the products. Simple projects make great educational tools. That's why I have built this one. So let's suppose in product I have ID, name, and price. Nothing special here. We simply have a product with an ID, name, and a price. The interesting part isn't the data itself, it's how we retrieve the data efficiently. Let's go to database simulator. This class basically simulates a slow database operation. So in reality, database don't intentionally sleep for 3 seconds, at least I hope not. But for demonstration purposes, we need an expensive operation so that the benefit of caching becomes obvious. So whenever we call this method, we wait for 3 seconds before running a product. So let's go to product service. So basically here I have used an concurrent hash map. And yes, you might be wondering why I am using a concurrent hash map instead of a regular hash map. So the reason is simple. In Spring Boot can handle multiple requests at same time and a normal hash map isn't thread safe. Concurrent hash map allows multiple threads to safely read and write to the cache. So even though this is a simple demo, we are still following good backend practices. When a request arrives, we first check whether the product already exists inside this map. If it does, we print cache hit and immediately return the response to the user. Otherwise, we print cache miss and fetch the product from a simulated database, store in inside the map, and then return it. That's it. That's literally caching. So let's run this application. I'll open Postman here to demonstrate the same thing. So let's start the application and see what happens. The server is up and running. So let's go through a quick demo on Postman using APIs, which has been exposed here to demonstrate the same thing. So I have four requests here. The first request is cache miss, which demonstrates the actual get of product through database. This operation basically, which we have discussed later, this one. So user directly calls to backend and then backend serves to database. Because currently we don't have cache, so it heads to the database and takes the response from there. So it can take time. So let's set it. So you can see it's taking some time to query database and get the response. So it have taken 3 seconds to get this response from the database directly. Now, after hitting this request, my cache has been stored according to our project logic. Now, let's go to second request. It's the same product with same ID. Now, the cache already contains it. So it would be a use case of cache hit. If I send the request, I get the response in 17 milliseconds. Too fast, right? Now let's clear the cache and see a cache miss use case. So I have an API dedicated to clear the cache so that we can easily clear it. You can see the cache cleared successfully. Now I have the same API. So number one and number two are the same APIs basically. It demonstrate after clearing cache the cache miss use case. So now I'm trying to get product with ID 1 again. You can see it takes the same amount of time which I've taken in the first request, 3 seconds, right? We didn't optimized SQL, we didn't buy bigger servers, we didn't scale horizontally. We simply avoided unnecessary work using cache here. So it brings back to the same thing. What happened? The first request had no stored information, so it went well all to the database. The second request already knew the answer, so the database didn't even know somebody asked the question. And honestly, database appreciates days like that. Now let me ask you a question. What happens if I restart the application? Will the cache still exist? Take a second and think about it. No, everything disappears because our cache lives entirely inside application memory, and that's where things become interesting. Let's suppose, imagine we now have three backend servers. Each server maintains its own local cache. User 1 reaches server A and gets a cache hit. Amazing, right? User 2 reaches server B and experience a cache miss. Wait a minute. Didn't we already fetch this information? Yes, but only server A remembers it. And that's one of the biggest limitations of simple in-memory caching. Also, there is another concept, cache invalidation as well. Suppose the iPhone price is 1 lakh and in cache the current iPhone price is 80,000. So the another challenge would be the data change, right? Suppose the product price gets updated inside the database, but our cache still contains the old value. Now users see incorrect information. Now think like for a real world example. Caching exists almost everywhere. Web browsers, cache images, CSS files, and JavaScript resources. Operating systems cache frequently accessed memory pages. Content delivery networks like CDN caches files closest to users. Applications cache database queries, user sessions, product informations. Once you understand caching, you start seeing it everywhere. Modern software simply wouldn't scale without it. Today, we have learned what caching actually is and why it matters so much. We saw the difference between cache hit and cache miss, but our solution still has significant limitations. The cache disappears when the application restarts, multiple servers cannot share data, we have no expirations policies, no distributed synchronization. And that's exactly why the industry uses tools like Redis. So, in the next video, we'll move beyond simple in memory caches and explore how distributed caching powers modern applications at scale. If you enjoyed this video, consider subscribing. I'll see you in the next one. Thank you.